Welcome to MyProjectBazaar.com. Now we can going to discuss about the project frequency support in microgrid using virtual synchronous generator based charging station. Now we can going to discuss about the abstract of our project. The system is entirely focused on electric vehicle of charging stations. The electric vehicle means for the only for battery resource. The battery resource can make a major use in our microgrid systems, and another you can see this project for frequency control of entire microgrids. So in our renewable source we can using the solar and wind turbines are using the in our renewable source, but we can using the maximum criteria of our wind turbine is an achieve the maximum CP level, and solar we can generate the maximum power level of these two microgrid generations using the synchronous generator. For this is an solar and wind are commonly connected to interface in common AC bus, so it will connected to the intermediate sections between the virtual synchronous generator is an both combination process, and again another side we can see for electric vehicle is nothing but we can see our batteries storage system. So this is an entire system and balanced using for virtual synchronous generator. The system has systematically improved, and frequency support will occur as bidirectional flow of our entire system is balanced. Now we can going to discuss about the flow diagram of our project. First we can see about the solar panel. We can using solar panel with the maximum power point tracking algorithm. So this is solar generate the maximum of power. Another thing we can see on left side for only for renewable resource solar and wind. So solar means as PV arrays and wind turbines we can using that, and we can see right side for electric vehicle. Electric vehicle is a battery storage system. It is particularly mentioned to about this process the solar array with the maximum power point tracking algorithms with maximum power generating. So this is process to the DC to AC converter bidirectionally. For these sections will move to the DC to AC converter. Is a some conversion process. This interface the common AC bus. When the wind turbine is generating for AC alternators, so this is no need for DC to AC conversion. So directly we can connect it to the bidirectional flow. This is another we can section. We can say the AC load will connected as is connected to in parallel in common AC bus. Some distortions will occur that this load will consume this distortions, and the filtering will using that this load type. Another thing, this excess of power is transmitting to the power converter. We can use for power converters for AC to DC converter similar that, but bidirectionally power flow is entirely controlled by virtual synchronous generator. So VSG controller is a main important part of our entire system. So this is an entirely control our two direction of control the powers, and these powers are change over to the common DC bus. The DC bus is using the electric vehicle. The electric vehicle battery something discharges or charges, as entire power will be consumed to this load. So our the entire load consumed. So virtual synchronous generator control that these sections of electric vehicle and some our renewable source. So is systematically our entire system has unbalanced, and system efficiency will be improved. Next we can going to discuss about the running procedure of our project. The proposed system implementation done in MATLAB version 2013A. The creating elements as per the circuit diagram of the base paper, and the corresponding scopes are connected in every scopes using the corresponding our particular circuits levels also. We are going to see about this. This is an entire topology of the circuit is a renewable source, and this is our electric vehicle process. So this is our virtual synchronous generator. So a lot of different subsystem will operate through that. Next we can see about discuss about the results. This is on our PV characteristics. So it's an 230 volt will be achieved that solar panel maximum power obtained that. This is an IV characteristics of solar panel. So x-axis is on voltage, y-axis is on current. So we can gradually decrease that. These are solar power outputs for voltage, current and irradiance level. Also 4 different level scopes will be given. Place and solar power is and solar voltage, short circuited voltage and short circuited current, open circuit voltage and short circuit current, and the solar power irradiance level. So 1000 irradiance level is maintained. This is an our battery outputs. This is an state of charge will occur that is an charge will be discharging the batteries. And current, the current will be improved and voltage will be also decreased. So this is then proportionally to each other. This and battery results. This is an our load consumed power voltage. This is a very high voltage will consume that. This is an starting for 0.19 voltage into 10 to the power of 4, because of 10,000 nearly kilowatt will consume that this voltage of load. So it will gradually decrease our loads levels. So this is maximum power consume the load. This is our entire system frequency level. Starting frequency is maintained for 15 and some distortions and noise using that is some frequency level fluctuating this reduced that frequency level. So this is on frequency output. This is on saturation and the switching pulse. This is a switching pulse of solar panel. Solar panel means for that our DC to DC converter switching pulses. This is on saturation region. So I guess this is on solar power using the filtering circuit. So because of maximum power is achieved that nearly 1500 power will obtain, and after we can decrease that some irradiance maintenance and voltage fluctuation and some distortions in load. So we see a lot of variations in this result. This is an VDC of solar panel. This is an DC to DC boost converter using the solar panel. So it's an gradually increase the VDC level. This is our entire virtual synchronous generator control. This is a switching pulse of our 4 switches. It's constantly 0 and first 2 switches are on and off, and another 3 and 4 switches are off and on. Is randomly on off process using for discharging or charging the electric vehicle. So we can it's automatically and switching pulse is change and generating and change it.